We live in an era overflowing with data, which creates a distinct sense of certainty. We have mapped the continents, tracked the ocean currents, and cataloged the surface of the Earth until it feels like we have the world figured out. To process all this information, we constructed massive physical systems. These rooms were filled with vacuum tubes and wiring, run by technicians whose sole job was to translate reality into neat, understandable numbers. This rapid technological progress led to a collective assumption. We look at our servers and our satellites and conclude that humanity is simply running out of mysteries to solve. But that sense of mastery only exists while we are looking downward at our own achievements. The moment we look away from ourselves, the math changes. When we aimed our hardware away from Earth, we built tools on a staggering scale. We embedded massive dishes into mountainsides, listening to the void. These instruments revealed a universe difficult to process. We found ourselves looking at billions of distant galaxies, each glowing point representing billions of individual stars. The scientific expectation was that sending signals into this expanse would eventually yield data as clear as our terrestrial maps. Yet, exploring deep space has illustrated a different reality. The further we extend our reach, the stranger and more completely unknown the universe appears. Based on probability, intelligent life should be common. When you take a single star and multiply it across billions of systems, the math points toward a universe teeming with worlds capable of supporting life. We have spent decades beaming signals into this grid, waiting for a reply from a population that the statistics suggest must be there. But despite the overwhelming probability, our exploration has been met with a total, unbroken silence. This contradiction between the high probability of life and the total lack of evidence is the Fermi paradox. It asks one question: where is everyone? This paradox indicates a massive gap in our understanding of how the universe actually functions. In the absence of confirmed scientific answers, unexplained anomalies fill the space. We are left with grainy photographs of objects moving through the sky in ways that defy our current understanding of physics. This leads to predictable friction. Scientists debate the data, governments issue official denials, and the internet transforms mystery into a fixation. However, there is a specific mechanism at work here. Our own observational technology created the context for this sense of isolation. Without the powerful machines required to see those billions of distant galaxies, we would never have been able to ask why we haven't heard from them. Every time we improve our capacity to see further, we define an even larger area of things we do not understand. Scientific discovery often upgrades the quality of our questions rather than simply eliminating the unknown. This is the geometry of ignorance. As our sphere of knowledge expands into a dark void, the surface area touching the unknown grows larger. Across every frontier, deep space, ocean trenches, and artificial intelligence, the boundary of what we still need to discover only stretches further. The Fermi paradox is a high-profile example of this. It is a mystery that only became possible once our technology grew enough to show us how much empty space was actually out there. If we ever reached a point of total certainty, we would lose our primary driving forces: curiosity, wonder, and the desire to explore. Exploration generally follows a pattern. Every answer we find tends to uncover a dozen new, more complex mysteries. No matter how advanced humanity becomes, the unknown will never stop growing. That is precisely what makes the universe worth exploring.